starting with the composition of functions. Composition of functions is another way to describe nested functions. And a nested function is basically a function inside a function. And if we look at this example right here, we can say that this is a combination of two functions. And if I look at 1 over x squared, this is 1 over something squared. And that something can come from another function and be plugged into a function to get a new function. And if we are given two functions, f and g, and it doesn't really matter what they're called, we just have two different functions defined by two different variables. We have the composition function is denoted by f with this little open circle g, read as f composed with g. Okay, and it kind of looks like this. Okay, f composed with g, our variable is x in both of the functions. And what that means is I'm going to take the x value, I'm going to plug it into the g value and get an answer. And whatever that answer is, I'm going to then plug into the f function to get a composed answer. Then it says the domain of the function, the composition of functions, is the set of all numbers x in the domain of g such that g of x is in the domain of x. And we're going to talk about domains specifically in a little bit. But if I look at the first example, I have two functions. I have an f function here that's defined by 2x squared minus 3, and then I have a g function that's defined by 4x. So they're asking us to find the composition of f and g with x being 1. So what I think of is I think that first of all, we're going to plug in 1 into the g function. So really what I'm finding is f of g of 1. Now g of 1 is 4 times our x value is 1. So this is 4 times 1, which is 4. Now I'm taking that value 4 and now plugging it into the f function, which is 2 times 4 squared minus 3. So this is 16 times 2, this is 32, minus 3 is 29. Now we're switching it around. I'm going to take 1, and I always work backwards or to the left. I take my variable. This time I'm plugging it into the f function. So I'm finding f of 1, and whatever value that is, I'm going to plug it into the g function. So f of 1 would be 2 times 1 squared minus 3. So this is 1 squared times 2 is 2, minus 3 is negative 1. So f of 1 is negative 1, and now I'm going to plug that into the g function, which is 4 times negative 1, which is negative 4. Here I'm taking negative 2, plugging it into the f function and getting a value, and then I'm going to plug it into the f function again. All right, so this is take the f function and plug in f of negative 2. So I need to find f of negative 2 first. So I'm going to go to the f function, and this is 2 times negative 2 squared minus 3. So this is 4 times 2 is 8, minus 3 is 5. So f of negative 2 is 5. Now I'm going to take 5 and plug it into the f function again. And I'm going to get 2 times 5 squared is 25, minus 3, so this is 50 minus 3 is 47. Now I've got the same concept, but I'm going with -1 into the g function. So I have g of -1 is -4. And now I'm going to plug that into the f function. So -4, whoops, nope, I'm going back to g. Sorry, misread that. So taking -4 and plugging it back into the g function again, which is 4 times -4, which is -16. All right, so looking at example 2, now we're going to look at the domain a little bit here. I have an f function, which is defined by x squared plus 3x minus 1, and a g function, which is defined by 2x plus 3. Now, if I look at each of these are both polynomials, so the f function, f of x, the domain is all real numbers. And the same thing for g of x. The domain is all real numbers. I'm going to separate that here. So now what I'm going to do, I don't have a value for x to plug in to a function. So this means I'm going to keep x as an expression, and I'm going to plug in whatever the g is, the g function is, I'm going to plug that into the f function. So f of g of x is 2x plus 3, and I'm going to take 2x plus 3 and plug it into the f function. Wherever I see an x, I'm going to plug in 2x plus 3. So this is 2x plus 3, and I square it, plus 3 times x, which is 2x plus 3, minus 1. And now I need to simplify. So if I multiply 2x plus 3 times 2x plus 3, I'm going to get 4x squared. And then I'm going to multiply the middle terms. 2x plus times 3 is 6x, and double it, so that's plus 12x. And then 3 squared is 9. And now I'm going to distribute the 3 here, plus 6x plus 9, and then minus 1. So here, I'm running out of room. If I simplify this, I have 4x squared, 12x plus 6x is plus 18x, and then I have 9 plus 9 is 18, minus 1 is 17. So simplified, this is what I get. So if I look at the domain of f of g of x, this again is a polynomial. So f of g of x, my domain is all real numbers again. Now I'm going the other way. I'm going to take the f function, which is x squared plus 3x minus 1, and I'm going to plug it into the g function. So I'm going to have 2 times whatever x is, and then plus 3. So this gives me 2 times x squared plus 3x minus 1, and then add 3 at the end. So this becomes 2x squared. 2 times 3 is 6x, minus 2 plus 3. Those are my only like terms. So this is 2x squared plus 6x plus 1. And simplified, that's what I have. And if I look at this value for g of f of x, I'm going to have another polynomial. So g of f of x is the domain of all real numbers again. Okay, so that is, looking at when I have two polynomial functions, one inside the other, generally I'm going to have the domain of all real numbers. But that's not the case so much when we're working with non-polynomial functions. So in this one, turn on a little light here, it's getting dark. So here I have f of g of x. So looking at g of x, I need to find out what my domain is for g of x. So my domain, looking at this, is all numbers except for 1. So x cannot equal 1. Now, I'm taking this and plugging it into here. Now, this domain, I know, in f of x, cannot equal -2. Okay, so whatever this is plugged into here cannot equal -2. So I'm going to take this value of g of x, which is 4 over x minus 1, and say, all right, that cannot equal -2. And if I simplify this, I'm going to multiply by x minus 1 on both sides. So that cancels, and I have 4 cannot equal -2x plus 2. Subtract 2. So 2 cannot equal -2x, and x cannot equal -1. So my other value is f of g of x, f of g of x. Do it this way. The domain is all values except for x cannot equal -1. So for the whole problem here, my domain will be, remember the set notation here, for all values of x, x cannot equal 1 and x cannot equal -1. All right, so here it says we have these same two functions as up here. We want to find f of g of x and the domain of each. So f of g of x, then we want g of f of x, and then we want the domain of each. Well, the domain of the first one is up here. All right, so I'm not going to do that all again, but I am going to do some calculating here. So when I am calculating here, remember I'm doing f of g of x. So I'm taking the g of x function, which is 4 over x minus 1, and I'm plugging this into where I see an x in the f function. So I'm going to have 1 over what x equals. So I have 1 over what x equals, which is 4 over x minus 1, and then plus 2. All right, so what I need to do here is I'm going to multiply my numerator and my denominator by this common denominator right here. So if I multiply this by x minus 1, and I multiply all of this by x minus 1, really I'm just multiplying by a value of 1. So this is just going to let me manipulate these values a little bit. Anything over itself is 1. And if I multiply 1 by anything, it stays the same, but we're going to write it a little differently. So on the top, I'm going to have x minus 1. And on the denominator, if I distribute this x minus 1, they're going to cancel here. So I'm going to be left with 4 plus 2 times x minus 1. So this gives me x minus 1 over, this is 2x minus 2. So this is 2x 4 plus negative 2 would be 2x plus 2. And if I look at what the denominator cannot equal here, this cannot equal 0. So if 2x plus 2 can't equal 0, subtract 2, you get negative 2, divide by 2, x cannot equal negative 1. And that's what we had up here. X cannot equal negative 1. All right, so now let's look at, let's go this way. G of f of x. So I have G of f of x. So now I'm looking at the domain for f of x. So f of x is 1 over x plus 2. So the denominator can't be 0, so x cannot equal negative 2. All right, now my g of f of x, for that domain, my g of x, I want to say this differently. This value right here cannot equal 1, but I'm putting in f of x into this spot, so I'm going to take my f of x function, which is 1 over x plus 2, and say that cannot equal 1 because that would give me a 0 on the denominator. So just like I did up here, I'm solving for x, and I'm going to multiply both sides by x plus 2, so that gives me 1 cannot equal 1 times x plus 2, so x cannot equal negative 1. All right, so f of x can't be negative 2, but this value here can't equal 1, and this value is going to be replaced with this function, so this function cannot equal 1, and that's where we got this. So x cannot equal negative 1. So now I'm going to take f of x, which is here, and I'm going to plug it in where I see x in g of x. So g of the function of f of x is 1 over x plus 2 is, now I'm going to take this and plug it in here. So I have 4 over 1 over x plus 2. Sorry, I made a mess here a minute ago. And then minus 1. So as I did up here, I'm going to get rid of this complex fraction by multiplying the top and the bottom by that common denominator. And that common denominator is x plus 2. So I'm going to multiply x plus 2 and then x plus 2 on the bottom. So on the top, I'm going to have 4x plus 8. Because I'm distributing here. And then on the bottom, I'm going to have 1 because the x plus 2's cancel, and then minus x minus 2. So this part right here is minus x, 1 minus 2 is minus 1. So this is really, I'll write it a little bit neater. 4x plus 8 over minus x minus 1. This is the value of g of f of x right here. And if I look at this domain, if this cannot equal 0, what am I going to have here? This is, let's look at that. Negative x minus 1 can't equal 0. Add 1, so negative x can't equal 1. So x cannot equal negative 1. And that's what I had up here. So that's my domain of this whole function. So my domain is going to be, for all values of x, x cannot equal negative 2 and negative 1. In example 5, it asks us to show that the two composite functions are equal. So here's my f function, here's my g function. They're asking us to show that f of g of x is the same as g of f of x, which equals x. So I'm going to start over here with f of g of x. And that will be, I'm going to take g of x, which is 1/3 times x plus 4. And I'm going to plug that into the f function. So the f function is 3 times what x equals, 1/3 times x plus 4. And then I'm going to subtract 4. Now, here, if I multiply 3 times 1/3, that's going to cancel. And I'm left with x plus 4 and minus 4, and those are going to cancel. So that gives me x. Now I'm going to go the other way and say g of f of x, g of f of x, and now I'm going to take the f of x function, which is 3x minus 4, and I'm going to plug this into the g function. So where I see an x in the g function, I'm going to plug in 3x minus 4. So I'm going to start with 1/3, and then x is 3x minus 4, and then plus 4. So inside the parentheses, I have minus 4 plus 4. Those cancel, that's 0. And then 1/3 of 3x is just x. So we're just showing that these two composite functions are the same, and when they're the same, they are equal. And this last part is probably the easiest of all the examples that we've done. Here they're asking us to write the g of f of g equals something. So we want to have basically break this down into two functions. All right, so the f function, the outside function, we're going to take and look at this and say, okay, we have something to the 50th power. So x to the 50th power, and that something inside is going to be g of x. So g of x is going to be x squared plus 1. So if I wanted to find f of g of x, I would take g of x and plug it in for x. So I would have x squared plus 1 to the 50th power. All right, so we're writing a pair of functions. So now I have my composite function is 1 over x plus 1. So if I say my f function is 1 over something, and that something is x plus 1. So my g of x function would be x plus 1. And example 8, same thing. Here is my composite function. So the square root of something will be my first function, and that something that goes inside the square root is g of x, and that would be x squared plus 1. All right, so there we have it with composite functions.